Hello everyone, we'll see what is acceptance by deterministic finite automata. For this we should know what is extended transition function. Extended transition function is represented by the symbol delta star. Let M with the tuple Q, sigma, Q naught, A and delta be any finite automata. If I write finite automata, it means it is DFA only. Let M be any finite automata or DFA. We define function delta star as Q cross sigma star to Q. What is Q cross sigma? Q is the set of state. Cross sigma star. Sigma star is the set of all possible strings over sigma to Q. Means on reading some string, it is giving some out. The function is giving some state from the set Q. Now for any Q that belongs to Q, that is small q that belongs to Q, that is any state that is in the set, delta star Q comma null is Q. Means ki this is the base case. On reading null, we are getting Q only. And for recursive case, suppose Y is any string, Q is the state, A is the symbol, delta star Q comma Y A is expanded as delta, then delta star Q comma Y comma A. We will make use of this expansion with some example. Let's see the example. Suppose the case 1 where I have the example delta star Q naught A double B A. For this deterministic finite automata, we have to expand this as delta star Q naught A double B comma A. Now further expand this delta star. This is delta star Q naught AB comma B comma A. Similarly, next step, again this delta star is expanded as delta star Q naught comma A comma B, this comma B comma A. Again one more step, Q naught comma null comma A comma B comma B comma A. Now remember what? By the definition, any state on reading null string will return this state only. So I will have this as delta. This is returning us Q naught A comma B comma B comma A. Now we have the diagram in front of us. Just make use of the diagram to return the values. Q naught on reading A. See the transition function Q naught on reading A. See this diagram. Q naught on reading A is going on Q1. So I have delta Q1 comma B comma B comma A. Similarly, Q1 on reading B. Q1 on reading B is going on Q1 only. So I have delta. This is Q1 comma B comma A. Similarly, next step, Q1 on reading B is going on Q1. So I have delta Q1 comma A. Now Q1 on reading A is going to Q1. So the output of this delta star Q naught on reading the string A double B A is giving us Q1, means stopping, the machine is stopped on state Q1. So similarly, try for this delta star, the second one, delta star Q naught BBA. So for this case, this is delta star Q naught double B comma A. Similarly, next step, delta star Q naught comma B comma B comma A. Delta star q naught comma null comma b comma b comma a. Similarly, this will give you q naught only, so I will write this as delta 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 q naught comma b comma b comma a. So finally, q naught on reading delta, q naught on reading b. By the diagram, q naught on reading b, I'll just take this page up a little bit up. q naught on reading b is going to state q2. So I have delta delta q2 comma b comma a. q2 on reading b is staying on q2 only. So delta q2 comma a. q2 on reading a is staying on q2 only. So q2 is the output of this delta star q naught bba. So when we take the string, if the machine reads double ba for this diagram, it is stopping on what state? It has stopped on q2. Now see the next concept, that is acceptance by deterministic finite automata. Let M is q sigma q naught e delta be any finite automata. A string x that is belonging to sigma star is accepted by machine M if delta star q naught comma x belongs to A. It means that A is the set of accepting state. If by reading x, machine has stopped on any of the state that is in the set A, we'll see that the machine has accepted the string. For example, just see the previous example. In this case, the first example, q naught on reading a double ba, this string, has stopped on which state? q1, and q1 belongs to accepting state. So therefore, q1 is there in the accepting state. Therefore, the machine M, this machine is accepting the string a double ba. This is the acceptance. Whereas in case of this example, the example 2, q naught on reading the string double ba has stopped on the state q2. It has stopped on state q2, which is not belonging. This q2 doesn't belong to accepting state A. So therefore, double ba is a string that is rejected by the machine. It is not accepted by the machine. So this is the definition of the acceptance. Further, the language accepted by M or the language recognized by M is the set. This set LM is having the string x that belongs to sigma star such that x is accepted by M. Means this set will have all strings, say x1, x2, x3 and so on, which is these strings are accepted by machine. That is when we apply extended transition function on any of these string, it should stop, the machine should stop on one of the accepting state. Hopefully this concept of acceptance of DFA is clear to all of you. Thank you all for watching this video.